Hello, ladies and gentlemen. Welcome to Math 30-3, Chapter 1, Section 3, Partial Variation, Part 4. God, never ends. But this is the last sample question I'm going to do. So, Jose's car has a full tank of gas, 40 liters. She knows that if she travels at a fairly constant speed, her car uses about 1 liter of fuel for every 9 kilometers of driving. So, let's make a table to represent the amount of fuel in Jose's car after she has driven 0, 45, 90, and 135 kilometers. So, distance traveled, 2 meters, versus fuel remaining, meters. 0 kilometers, 45, 90, 135. So, she starts with 40 liters, said so in the question. What did it say? Yes, starts with 40 liters. So she drives 9 kilometers, she loses a liter. She drives 18 kilometers, she loses 2. Now what I'm trying to point out here, 9 times 5 is 45. So she should lose 5 liters of fuel and be down to about 35. Every 9 kilometers, she loses a liter. 9 times what is 9? 10. So she should lose 10 liters and be down 30 liters. 135 is actually 9 times 15. So she should burn 15 liters of fuel. 40 minus 15 is 25. So there's our data points. We get the plot. Okay? So quickly looking at this, we have the distance, kilometers. Now, no, we have to go 15, 30, 60, 90, 120, 150. All right? So if you tick mark, every tick mark becomes 15 kilometers. And this will be fuel remaining. In liters. Now this is one of the few times it doesn't deal with money. But anyway. So looking at these data points, 0, 40. Oh, sorry. Fuel remaining. 10, 20, 30, 40 liters. Yeah, that's how we have to fit in. So, 0 kilometers, 40 liters, drives 45 kilometers, which is here, 35, drove 90 kilometers, we're down to 30 liters, 135 is halfway between 120 and 150, we're down to 25 liters. Woo! Now, I admit I did that kind of quickly, because I already did this and forgot to turn on the recorder, so I actually know the numbers. Anyway, try that again. So there we go. And that's roughly what I got. Now, if I'm going too fast for you guys, pause the recording and get caught up. So you should be able to draw the graph based on these, poopy head, these data points we came up with. Right? So if I'm going too fast, pause the recording, get caught up. Otherwise, actually I'm going to pause the recording, let you get caught up, then we'll answer some questions. Okay, welcome back. Now, should you connect the points on the graph? Yes. Why should we connect the points? Because this is discrete. That is, you can drive 15 kilometers, you can drive 14.9, you can drive 14.91. It's a continuous line. It's not like walking, taking steps where you can take 1 step or 2 steps. Here you can drive a kilometer, half a kilometer, or a fraction of a kilometer. So calculate the slope of the line. Well, I can tell you what it is. She drives 9 kilometers, and it costs her 1 liter of fuel. No, actually, I should show that to you. Slope, rise over run. In this instance, not here. Hey, stop that, people, won't you? This is easy to calculate. The run, oh, sorry, I should stop here at the last data point. So a run, we start at 0 and we go to 135 kilometers. And our rise is how much fuel is left, or minus 15 liters. So I actually got that backwards. Rise is minus 15 liters for 135 kilometers, which is minus 1 liter, 9 kilometers, which is the rate of fuel consumption. And why is the slope negative? She's using gas. Okay. So about how far can Jose travel before running out of fuel? Well, slope. Minus over run. Minus 1 over 9. Now, slope is 1/9. The question is, what's the rise and what's the run? Well, we start at 40 liters, and we're going to 0. Run out of fuel, so that would be minus 40 liters over x kilometers. So we have to solve for x. So to do that, we do a little cross multiplying. Minus 1x equals minus 40 times 9. It's minus 260, I believe. Now we multiply both sides by minus 1, so x is 360 kilometers. So she can go about 360 kilometers before she runs out of fuel. Okay? Now, finally, let's do this one quickly. Henry has a bi-monthly food budget of $450. The following graph shows an approximation of how much money is left in his budget each day. Okay, not the best graph, but you see. 500, 400, 300, 200, 100 days. So $450 a month in $450 in 30 days. Oh, you poopy head. Okay, let's get to the question. Estimate how much money is left in his food budget after 1.5 days. Now that's difficult to do, because looking at this graph, we're interpolating data. 5, 1.5 is something like that. He's going to have like really close to 450. But that's tough to estimate. I'm going to say like $440. That's a big question mark. It's much better if we calculate the slope. Slope is rise or run. In this instance, he's spending $450 over 30 days, which works out to be minus $15 a day. Per day. So every day he's spending $15. Now, $15 a day times 1.5 days is 22 over 50 he'd spend here. So the better answer, so the actual answer is 450 minus 2250, which is, I can't do that in my head anymore. I'm double checking my math. $15 a day times 1.5 days is 2250. So 450 minus is 427.50. So I guesstimated 440 from the graph, but that was a horrible estimation. It's actually closer to 4:30. Right? So that's what you should be able to do when I give you a graph. Now, that's it for this lesson. A lot of questions. Fortunately, there's not that much work. So if you've got any questions, shoot me an email. Otherwise, work on the classwork.